Hi there, this is lesson 1.7. We're dealing with maxes and mins, talking a little bit about maximums and minimums on a function on a graph, and also looking at some more transformation stuff to finish this up. This will be the last lesson before our first test. This first test is going to be Friday, so be ready for that. I'll include a review on today's page, and you'll have tomorrow to work on that. And I'll give you the answers to the review at some point. Probably I'll post those tomorrow as well. Um, and then we'll have the test on Friday. Okay? All right, we're looking at lesson 1.7, maximums and minimums, and we're also going to look a little bit more at transformations. So, first thing it tells us is we're given this graph, and it says give the intervals where the function is increasing and where it's decreasing. So it's going up from left to right from negative infinity until it hits this point here, which happens at -2. Remember, always for intervals, we're giving x values. So from negative infinity to -2, it's increasing, and then it decreases. Starting at -2, decreases until it gets down here, and that happens at 3. So decreasing from -2 to +3, and then to the right of 3, it's back increasing again. So from 3, and then it goes on to infinity, it keeps increasing. Okay? So, since f is blank to the left of -2, x equals -2, so to the left of that it is increasing. Increasing to the left of -2, to the left of x equals -2, and to the right of x equals -2 it is decreasing. So it's increasing to the left of a point, it's decreasing to the right of a point, and when that happens we have to have a maximum at that point. Maximum at x equals -2. The maximum in this particular at x equals -2, the maximum value is 4. The maximum value is 4, and that occurs at x equals -2. Likewise, over here at 3, to the left of 3, it's decreasing. And to the right of 3, it is increasing. And when that happens, we're decreasing to the left, we're increasing to the right, and at the point itself, we're going to hit a minimum. All right, so we have a minimum at x equals 3, and the minimum of f at x equals 3, the minimum value itself is 0. It's on the x-axis, so it's 0. Okay, and this is always going to be true. If you're increasing to the left of a point, decreasing to the right, then we have a maximum. If it's decreasing to the left, increasing to the right, then we're going to have a minimum. So, let's look at example 1 here. The figure below shows the graph of f of x. At what value or values, if any, does f have a maximum? Well, I've got a high point over here, it looks like, and that's happening at x equals -7. And then I've got another high point over here, and that's even happening at +7. X equals +7. So at what value? That's happening at x equals -7 and at x equals +7. What are the maxima? All right, what are those values? Well, they both are going to be 3. Okay, they are both 3. So justify your answer. Well, f is increasing to the left of x equals -7 and x equals 7. F is decreasing to the right of x equals -7 and x equals 7. And when that happens, when I'm increasing to the left, decreasing to the right, it has to be a maximum. Alright, so where do we have a minimum? Well, we have a minimum right here at x equals 0. What is the minimum? It looks like that's -4. Domain for this, we're going to assume that this is just continuing on, so it's going to go forever to the left, forever to the right. It looks like all real numbers here. We're going to assume it's all real numbers. Is it even, odd, or neither? Well, it looks like it has y-axis symmetry, right? Y-axis symmetry. And if it has y-axis symmetry, that means it's an even function. the range? Well, it's going down forever, I can see that, but it's not going up forever. The highest point is 3. So I'm going to say from negative infinity to 3 with a bracket, indicating that it includes the 3. Alrighty? Okay, more transformations then. So, we're given a point. If 5, negative 1 is a point on f of x, what will be the corresponding point on the following transformations of f of x? Alright, so remember that f of x is y, so we're simply going to do 3 times y here. So my point's going to be 5, comma, 3 times my y value, which was negative 1. So that point would be 5, negative 3. Okay? Alright. When I'm in the parentheses, I'm going to put that equal to my x value. I'm going to say, alright, x plus 4 equals 5. Subtract 4 from both sides, and I get x equals positive 1. So my x value is positive 1, my y value is negative 1. 1, negative 1. Alright, so inside to my x value, I'm going to say 2x equals 5. So x is equal to 5 halves. That's my x value. Now I'm going to rewrite this one a little bit. I'm going to say negative of f of 2x plus 3, because this is a positive 3. So I'm just kind of writing it more the way we've been having a function plus or minus something. So basically that plus 3 is going to be shifting things up 3. So I'm going to take the opposite of my y and I'm going to add 3. So my y was, I'm going to take the opposite of negative 1. We'll add 3, so this is going to be a positive 1 plus 3 is 4. So my point is 5 halves 4. 5 halves, comma 4 will be on the graph. Okay, we're looking at number 3. Given the graph of f of x at the right, graph and write the equation for each transformation of f of x. So I've written down the points, negative 8, negative 4, 0, 4, 4, negative 2, and 8, negative 2. I can see that we're going to need this in just a minute. I can see that the domain here for this function goes from negative 8 to positive 8, inclusive. And the range goes from a low point of negative 4 and a high point of positive 4, inclusive. Alright, so part A says the domain of the transformation is negative 4 to 4. Notice up here it was negative 8 to 8. So it looks like I'm doing a horizontal shrink here. Horizontal shrink times 1/2. And the range is negative 6 to 2 with an x-axis reflection. So let me write that down, x-axis reflection. So that means all of my y values are flipped, right? If I do an x-axis reflection, all the y values flip. And so now what was my highest point at positive 4 should now be negative 4, and my lowest point, negative 4, should be positive 4. But instead it's negative 6 and 2, so not only do I have the x-axis reflection, but I'm shifting down 2. Okay? So, just shifting this up just a bit to write my equation. I'm going to say y equals, I know it's going to be, remember inside the parentheses I do the opposite of what's actually happening. So this is going to be f of 2x. I need an x-axis reflection, that's a negative sign in front of the f of x. And I want to go down 2, I'm going to subtract 2 here. So there's my equation. And I'm going to make myself another little table over here. So all the x values get divided by 2. Negative 8 becomes negative 4, 0, 4 becomes 2, 8 becomes 4. So now my domain is from negative 4 to positive 4. And the y values are going to change signs from the x-axis reflection and then subtract 2. So negative 4 goes to positive 4. And then I subtract 2 and it becomes a 2. 4 goes to negative 4. I subtract 2, it goes to negative 6. Negative 2 goes to positive 2, and subtract 2, I have 0. And same thing for this, negative 2 to positive 2, subtract 2, I get 0. So negative 4, 2, 0, negative 6, 2, 0, 4, 0. And let me just draw my lines in here. Okay, and so you can see I have a horizontal shrink, flipped upside down, shifted down 2. Part B, the maximum is 0 at x equals negative 2 with no reflections and no stretches or shrinks. So all I have going on here is shifts. The maximum was at 4, now it's at 0, so I'm shifting down 4. And that maximum occurred at x equals 0, and now it's at x equals negative 2, so I have to go left 2. So for my equation, the left 2 goes inside the parentheses, does the opposite. I would think left 2 would be minus 2, but it's going to be plus 2. And then down 4, it's going to be a minus 4. So my x and y values here, I'm going to subtract 2 for all the x's. So negative 10, negative 2, 2, and 6. For the y values, I'm going to subtract 4. So negative 8, 0, negative 6, negative 6. So negative 10, negative 2, negative 2, 0. Oh, I'm sorry, negative 10, negative 8. Negative 10, negative 8. Negative 2, 0. 2, negative 6. And 6, negative 6. Right. Oops, overshot that just a little bit. There we go. Okay. So you can see it shifted 4 to the left. Excuse me, 2 to the left, 4 down. All right. Okay, I hope that all made sense to you. If you have any questions, let me know. Otherwise, remember there's a test on Friday. And if you have questions about stuff on the review, again, just get in contact with me and I'll try to straighten you out. Okay? Best of luck to you. I hope you are all doing well. Bye-bye.